You think temperature needs stuff, atoms, molecules, motion. You picture heat as something trapped inside matter. So when you imagine empty space, you imagine nothing. No particles, no motion, no warmth, just a silent, frozen backdrop. That picture feels obvious. It feels safe. It feels untouchable, and it's wrong, not subtly wrong, structurally wrong. Because even when you remove the stars, even when you remove the gas, even when you remove everything you think can carry heat, space refuses to become temperatureless. You were taught that temperature measures how fast particles move, but space has a temperature anyway. Not metaphorically, not approximately, a real number, measurable, unavoidable, which means one of your assumptions is broken. Either temperature is not what you think it is, or emptiness is not empty, and both options should bother you. You learned temperature as a speed, not officially, not in those words, but that's how it lodged itself in your mind. Hot means fast atoms. Cold means slow ones. Absolute zero means they stop. This picture works disturbingly well. It explains why metals expand, why gases push harder when heated, why flames burn and ice numbs, so you stopped questioning it. But notice what you quietly assumed. You assumed temperature belongs to matter, that without particles the concept collapses. This is the first mistake. Because temperature was never defined as motion. Motion was just the easiest place to see it. If temperature were only about particles moving, then a gas with one atom would have a temperature. It doesn't. A single particle has energy but no temperature. That should bother you. Temperature only appears when energy can be shared, when there are many possible arrangements, when a system can forget its exact details. Already, this has nothing to do with matter specifically. It has to do with statistics, with counting, with ignorance. You don't measure temperature by tracking particles. You measure it by giving up on tracking them. A thermometer doesn't watch atoms bounce. It waits until something settles, until energy distributes itself in a stable way. Temperature is a description of that stability, of what energy does when no one is forcing it. Now imagine stripping the system down, fewer particles, less structure, less stuff. At what point does temperature vanish? Not when motion stops, not when matter thins out. It vanishes only when no sharing is possible. And here is the crack in your intuition. Because emptiness, as physics understands it, is not a single frozen state. It still allows arrangements. It still allows exchange. You were taught a picture that works for solids and gases, but it was never the definition. It was an example, and examples break when pushed. If temperature were truly just motion, vacuum would be meaningless, a perfect blank. But physics never gave vacuum permission to be simple. This isn't a technical loophole. It's a conceptual failure. Your definition of temperature collapses before space even enters the conversation. You imagine empty space as black. Not metaphorically, literally, a canvas with nothing on it. No glow, no haze, no background hum. If there's nothing there, there should be nothing to see. And yet, when we finally looked carefully enough, space answered back, not near stars, not inside galaxies. In the vast gaps between everything, a faint, uniform glow, the same in every direction, not attached to any object. This is where the intuition breaks again, because this glow is not debris. It's not leftover heat leaking from nearby matter. It doesn't fade when you move away from structure. It fills space itself. At first, this felt like a historical accident, a remnant from a hotter past, a fading echo, but that framing is comforting. It lets you keep the old picture: matter was hot once, and space is just holding the leftovers. That story is incomplete, because this radiation doesn't behave like ash. It behaves like a system in equilibrium. Its spectrum is precise, too precise, the signature of a temperature, not a guess, a number. If space were merely a container, this radiation would thin, distort, or fragment. It doesn't. No matter where you look, no matter where you go, space presents the same thermal fingerprint. Which forces an uncomfortable question. If temperature requires matter, what exactly is at that temperature? There are regions where particle counts drop to nearly nothing, 1 atom per cubic meter, sometimes less. Yet the temperature doesn't care. This is not heat flowing through space. This is space refusing to be thermally undefined. You can remove stars, you can remove gas, you can remove dust. The glow remains, and the deeper problem is this: you cannot assign this temperature to objects. It doesn't belong to galaxies. It doesn't belong to clouds. It doesn't even belong to radiation sources anymore. It belongs to the background itself, which means space is not just hosting energy. It is participating in its organization. This isn't a violation of physics. It's a violation of expectation, because nothing you were taught prepared you for temperature without substance. The universe showed us this quietly. No announcement, no drama, just a faint warmth where nothing was supposed to be. At this point, it's tempting to cheat. To say, fine, space has radiation in it. Radiation is something, so temperature still belongs to stuff. That move feels reasonable. And it preserves your intuition, but it doesn't survive inspection. Because radiation is not matter. It has no rest, no shape, no place to sit. You can't point to a photon and say where it is. You can only say where it interacts. And yet, a bath of radiation can have a temperature. Not because photons bump into each other. They mostly don't. Not because they collide and settle down. They don't need to. Temperature here doesn't come from contact. It comes from distribution. This is the shift your intuition resists. A thermal state is not defined by collisions. It's defined by how energy is spread across what is allowed. Radiation has allowed states, frequencies, modes, ways it can exist. When those possibilities are populated in a very specific balance, we call it a temperature. No particles slowing down, no friction, no mixing, just statistics. This is why a cavity filled with light can settle into a thermal spectrum even if the walls are removed. The walls were never the point. They only enforced constraints temporarily. Once the distribution exists, it sustains itself. And here's the quiet consequence. If radiation alone can define temperature, then matter was never essential. It was incidental. Matter just made temperature familiar, visible, tactile, but the concept itself lives deeper. This is why empty regions of space can still be warm in a precise sense, not warm to your skin, warm as a description of possibility. Energy is not sitting somewhere. It is allowed to be many things, and it occupies those options evenly. Temperature is the name we give to that evenness. At this point, the question changes. It's no longer how can space have a temperature? It becomes what does space allow energy to do when nothing else is there? Because if space were truly nothing, there would be no spectrum to populate, no balance to strike, no temperature to define, and yet the balance exists, which means the emptiness itself is already doing work. You still picture space as a stage, a silent platform where physics happens, a place, not a participant. This is the last comforting image. Because modern physics never treats space that way. Not anymore. Space is not an absence. It is a set of rules that never turn off. Fields exist everywhere, not floating in space, defining it. Even when no particles are present, those fields are still allowed to fluctuate. Not violently, reluctantly. This is where intuition starts to fail completely. You expect nothing to stay nothing. Physics doesn't allow that luxury. Every field has a lowest energy state. But lowest does not mean zero. It means as quiet as the rules permit. And the rules permit very little quiet. Energy cannot be perfectly pinned down without spreading out in time. Space cannot be perfectly empty without allowing uncertainty to move through it. So even in the absence of particles, space hosts possibilities. Transient, ephemeral, but real in their consequences. These fluctuations are not heat, not yet, but they are not nothing. They define what energy could do if it were allowed to settle. This is the crucial shift. Temperature does not require activity. It requires availability, the ability for energy to be rearranged within constraints. Space provides those constraints automatically through its geometry, through its fields, through the limits it imposes. So when radiation exists, space does not just let it pass. It shapes its allowed forms. When nothing exists, space still enforces the menu. This is why emptiness can never be stripped bare. There is always a structure left behind, not material, not tangible, but restrictive, and restriction is enough. Because the moment energy appears, even briefly, even virtually, space already knows how to distribute it. Temperature is not stored in space, it is permitted by it. And a system that permits energy to spread in balanced ways cannot be thermally meaningless. By now, emptiness has lost its innocence, but the most unsettling part is still ahead, because even this temperature is not the same for everyone. Up to now, you've been allowed one last refuge. You could still believe temperature is objective, that it exists the same way everywhere for everyone. Space may have structure, fine, radiation may fill it, fine, but surely temperature itself is absolute. This belief does not survive motion, not fast motion, not extreme motion, just the wrong kind. Imagine drifting through empty space, no stars nearby, no radiation you can point to. Nothing changes. Now imagine accelerating. Not toward anything, not away from anything, just accelerating. Suddenly, something appears, not a force, not particles rushing in. A temperature. From your perspective, space warms up. This is not metaphor, not illusion, not equipment error. According to the laws of physics, an accelerating observer perceives a thermal bath where an inertial observer sees nothing. Same space, same fields, different motion, which means temperature is not just out there. It depends on how you move through emptiness. This is where intuition gives up. No heat source was added. No energy injected from outside. Nothing physical changed in space itself. Only your trajectory did, yet temperature emerged. This tells you something uncomfortable. Temperature is not a substance. It is not even a property of space alone. It is a relationship between an observer, the structure of space, and the limits of what they can access. Acceleration creates horizons, boundaries you cannot see past, and boundaries change what balance A means. Energy that was evenly distributed across all possibilities is no longer accessible to you. What remains looks thermal. Not because space heated up, but because your access to it shrank. Temperature here measures loss of information, not motion, not matter. This is the point of no return. If temperature can appear without particles, without radiation sources, without even a static space, then temperature was never about objects. It was about how reality parcels itself to observers embedded within it. And if that's true, there may be no such thing as perfectly cold space. Absolute zero feels final. A hard floor, a place where physics goes quiet, no motion, no heat, no energy left to drain. You imagine it as a destination. Something space should naturally reach once everything cools down enough. This is another comforting picture, and it is unattainable not practically, but conceptually, because absolute zero is not just cold, it is perfect certainty. It would require energy to be fixed with no remaining options, no alternative arrangements, no fluctuations. Physics does not permit this. Even the calmest state allowed by the rules still contains spread, not activity, but possibility. You can lower energy, you can reduce excitations, you can remove matter entirely. What you cannot remove is the structure that defines what energy could be. This is why cooling systems stall, not because of engineering limits, but because each step toward zero demands more control than the universe allows. And space itself is no exception. If space had a true ground state with no residual structure, temperature would vanish cleanly. It doesn't. There is always a background, always a lowest allowed agitation, always a limit to how quiet reality can be. This is not heat hiding somewhere. It is not leftover energy refusing to dissipate. It is the impossibility of erasing uncertainty. Absolute zero is not forbidden because we lack tools. It is forbidden because temperature is not a dial you turn to nothing. It is a measure of how constrained energy is, not how much of it exists. And constraints never disappear. Even an empty universe cannot escape its own rules, which means the coldest possible space is not zero. It is simply the most orderly chaos allowed. By now, temperature has slipped away from matter. It no longer lives in particles. It doesn't even require radiation. So what exactly is it measuring? Not energy itself. You can have enormous energy with no temperature at all. Not motion, not substance, not activity. Temperature measures how many ways energy can be arranged without changing what you observe. That sentence should feel slippery, good, because temperature is not about what exists. It's about what is allowed to vary unnoticed. A system with many hidden possibilities feels warm. A system with few feels cold. This is why a single particle has no temperature. There are no alternatives to average over, nothing to forget. Temperature appears when description replaces detail, when you stop tracking microstates and accept a blurred picture. Space, even when empty, forces that blur. It defines fields, it defines modes, it defines horizons. It limits what can be known at once, and wherever limits exist, temperature can appear. This is why two observers can disagree about how warm space is without contradiction. They are averaging over different possibilities, forgetting different things. Temperature is not a property of reality alone. It is a property of reality under description. This is deeply unsettling because it strips temperature of its physical comfort. It becomes abstract, relational, contextual, yet still measurable, still real. You cannot point to temperature the way you point to matter. You can only infer it from what remains stable when details are lost. Space, by its nature, forces loss, not because it is violent, but because it is vast, structured, and indifferent to observers. And in that indifference, temperature is born. One last step remains. What does it mean for a universe that doesn't need us to be warm anyway?